Okay, naming compound sheet. Let's look at the first one, or the first one that's not already done for you. So this is what we do. So the first one, we got copper 3 chloride. Look at my periodic table. Copper's typically got a +1 or a +2 charge. This one's called copper 3, which means it's got a +3 charge. Chloride always has a -1 charge, so we would crisscross those charges. That would tell us what it's going to be. So the formula is going to be copper, and we're going to need one of those, and we're going to need 3 chlorines. So it's copper 3 chloride, and of course that is a metal plus a non-metal, so it's an ionic. And of course copper is a transition metal. So we look at the next one. Silver. Silver is also a transition metal. And silver plus iodine. And since we've got one silver compared to compared to 2 iodines, so that means silver is going to have a +2 charge, because iodine, which we will call iodide, has a -1 charge. So a -1 here. So 2 of these, that means that in order to balance this out, this would have had to be a +2. So that means 1 silver to 2 iodides. All right, flip the page so I can show you number 16 that I messed up on. So that, you get rid of that. So this is manganese, which is Mn. And manganese is Mn, and it is a transition metal. So it typically has a +2, +3, or +4. And I'm sorry, I was right with this. I actually did need the +2. My bad. I got a little sidetracked again. So it is a +2. So what I'm telling you is this is manganese with a +2 charge. And we're going to phosphide. And phosphide is just phosphorus, which has a P. So phosphide is phosphorus. Phosphorus typically has a -3 charge. So that means that if this has a -3 and this has a +2 charge, then that would mean, this has a +2, this has a -3. That means you crisscross those charges, which means we need 3 of these to 2 of these. So that's 3 times +2, which is a +6. This is 2 times -3, which is a -6. And -6 and +6 balance each other out. So the equation, or the formula, is Mn3P2. And of course, that's a metal plus a non-metal, so it's ionic. All right, so let's do number 23. This is calcium plus this weird looking thing. So it's got 3 elements. So that means automatically, you know, that's a polyatomic ion. This NO3, when we look over here on this sheet, which is just mine, it's also at the top if you flipped it over. But NO3 is right there in green, and that is a nitrate ion. And nitrate ion happens to have a -1 charge. Calcium, we know, has a +2 charge, which is why we have to have 2 of these to balance out the 1 of these. So we're going to name it. So this is going to be calcium. And since it's polyatomic, we don't need any kind of prefixes or any kind of numbers. So it's calcium, if I spelled that right. Remember, I'm not counting off for spelling, as long as it's close. And it should be nitrate. All right, so now we're going to do this one just so we can do a covalent. So this is obviously iodine, which is a nonmetal, and oxygen, which is a nonmetal. So those would be covalent. So iodine, so it's iodine, and we've got 2 oxygens, so that's going to be iodine di for the 2, oxide. Following the rules on our flow chart, which says that if it's covalent, then we need to use the Greek prefixes. And I just lost where I wrote it, so there we go. So that would be using the Greek prefixes. And those directions come from the flow chart, which was this thing. So again, we have covalent, so 2 nonmetals. The first one, we don't need to put mono if there's only one, and there was only one, so we don't have to write mono calcium. We don't have to write monoiodide. But since we had 2 oxygens here, we need to write the di for the 2 oxygens. So we come over here and we got 2 oxygens. So that's di. Then we get rid of the ending and we write "ide," so it's iodine dioxide. All right, one more of the covalent. So we're going to do number 17 here. So that's going to be covalent. And that gives us 2 carbons. So that's dicarbon. And it tells us that we got 6 bromides. So 6, we come over here and we find the prefix for 6, which is hexa. So it's hexa. So it's dicarbon hexabromide. My paper slide. Hold on. I'll write it and then I'll show you. So it's dicarbon hexabromide. All right, that's how you do this sheet. Remember, if you can figure out how to type it and submit it. If not, you can either print it and handwrite it, or you can just handwrite it on a sheet of paper, copy the answers, and then submit everything on Google Classroom. Okay, this paper is due Monday, high grade. That atom count paper that I just posted a video of, that one is due Tuesday as a mid-grade, and then the bonding quiz or bonding test is due Wednesday, high grade. Okay, be looking for more Edgenuity coming at you. I'm going to give it a new course name is what I'm thinking. So be prepared for that. All right, thanks.